Hello again. Hopefully the audience is still with us to hear these wonderful speakers that we have for this next time. This panel 2 is about enabling solutions for climate transition, science and innovation, enabling solutions, because it's important to know how to use science and innovation to power and develop solutions to support preparedness for a green transition. Well, we have our keynote speaker is Helena Pereira, President of the Board of Directors, Fundação para a Ciência e Tecnologia, well, translating Science and Technology Foundation, right? And Helena Pereira has a degree in Chemical Industrial Engineering from Instituto Superior Técnico and a PhD from the Faculty of Biology of the University of Hamburg in Germany. Helena Pereira is a full professor at the School of Agriculture of the University of Lisbon. Her research has mostly focused on forest products, including biomass and biorefineries in an integrated and multidisciplinary perspective. Welcome, Helena. You have, can you hear me?
Yes, I
can. Well, we have something to hear from you about climate challenges, right? Innovation and solutions supported by European and national funding instruments. Absolutely crucial for this time and to mitigate some of these aspects that are so important.
Yes, good morning to everyone from our sunny Lisbon. We have a very beautiful morning today. Well, you are totally right that climate change is an inevitable issue of the 21st century. It is a global threat that affects human health and well-being, ecosystems conservation, but also exacerbates inequalities, producing poverty and hunger. It is a societal challenge that crosses generations and ignores borders. Climate change is, however, not a new issue at the scientific and political levels. Already 25 years ago, in 1988, the World Meteorological Organization and United Nations Environment Programme created the IPCC, the Intergovernmental Panel on Climate Change, a United Nations body for assessing the science related to climate change. IPCC provides regular assessments of the scientific basis of climate change, its impacts and future risks, and options for adaptation and mitigation. The underlying issues on climate change are complex, cross-cutting many disciplines, from exact and natural sciences to engineering and social sciences, and involving all layers of society players. And it is now well accepted that we lack on knowledge and therefore a strong commitment regarding the enhancements of science has to be made. Again, tackling the different levels, from the phenomena understanding to accurate and global observation and monitoring, competence to deal with huge data, the study of impact, prevention and mitigation on the various activities, and the design of social awareness, commitment and change processes. Such endeavor on research and innovation increase on climate issues requires, of course, a firm commitment of governments with a strong financial envelope. We have now seen it globally across multiple countries and regions. In Europe, the focus on climate change is clearly embedded in our renewed European research area. Allow me now to introduce the case of my country, Portugal, as an example, and of the action of the National Science Funding Agency, the Foundation for Science and Technology, or FCT as we call it. Considering Portugal's vulnerability as a climate change hotspot, climate action represents both a national priority and a strategic challenge in terms of research and innovation efforts, and the continuous development and assessment of emerging technologies that may play a crucial role in national climate resilience strategy. FCT has been providing scientific support on the topics of the IPCC special report on global warming of 1.5 degrees, such as greenhouse emissions, threat of climate change, anthropogenic CO2 emissions and other emissions, greenhouse gas removal, emissions pathway, decarbonization, carbon budget, surface temperature, carbon dioxide removal, and other aspects. Between 2017 and 2019, the Portuguese researchers produced and contributed to 229 papers on these IPCC topics. And now we are just finishing, in collaboration with Portuguese Environment Agency, our strategic research and innovation agenda on climate change that will span to 2030. Let me now show you in more detail how FCT, as the national science funding agency, is supporting climate-related issues. FCT is an important agency in Portugal that funds the various components of the national science ecosystem. We can group the different commitments in 5 classes. First of all, the infrastructural backbone, including namely research centers and scientific infrastructures. Second, the people, a most important aspect, of course, researchers' employment and advanced formation for doctoral degrees. In third, we have ideas through the funding of research and innovation projects. International cooperation, the fourth, certainly with Europe, but also globally, and with a special focus with the Portuguese-speaking countries. And we have as our last fifth commitment, a transversal support regarding, for instance, advanced computing, digital connectivity network, and the support to open science. A few examples. We fund at least 10 research units dealing with various aspects of climate change. We also fund 4 collaborative laboratories. These are units that combine research groups with knowledge transfer units, as well as with the knowledge users entities, mainly enterprises. And we fund research infrastructures. For instance, for Biota, the Portuguese infrastructure for information and research on biodiversity. Tech4C, an infrastructure that develops the monitoring and observation of the ocean, namely the deep ocean. And let me stress one particular infrastructure, the AIR Center, the Atlantic International Research Center. It promotes an integrative approach to space, climate, ocean, and energy in the Atlantic, from pole to pole, supported by emerging technological innovations and advances in data science. Over the period 2015 and 2020, FCT also funded research contracts, projects, and PhD grants related to climate. They represent between 5 and 10% of the total R&D expenditure from FCT for these instruments. Of course, international cooperation is of very high importance. Of course, within ERA, for instance, in joint program initiatives, GPI Oceans for healthy and productive seas and oceans, GPI Climate for connecting climate knowledge for Europe, GPI Water, so water challenges for a changing world, and in networks of R&D funders and managers, the Biodiversa and the Ocean Era Net. And we are also involved in cooperation with other regions. We are deeply involved in the joint Africa-EU strategy and on the Union for the Mediterranean Regional Platform on Research and Innovation, as well as in the joint initiative for research and innovation that is established with Latin American and Caribbean. One example in more detail, one that is close to our hearts, Anchor, an all-Atlantic cooperation for ocean research and innovation. FCT coordinates this science diplomacy for year project that started in 2018. It supports the implementation of the Galway and the Ballet statements and other agreements between the EC and Argentina, Cape Verde and Morocco in scope of the All-Atlantic Ocean Research Alliance. The innovative activity of this alliance is the way we look at the cooperation needed to tackle common Atlantic Ocean issues and how we can tackle them together, including climate change effects in the ocean through new and long-term institutional arrangements that allow sharing of data, information and knowledge supported by increased infrastructure, use optimization, increased capacity building activities, and an ocean literate society. This coordination activity is seeding, we hope, long-term platforms in the areas of capacity building, data management, knowledge transfer, ocean literacy, and infrastructure sharing that we think will be crucial to identify solutions facing oceans stressors on climate changes. In the scope of the Portuguese presidency of the Council of the European Union, PT will host the All-Atlantic Cooperation in Research and Innovation for a Sustainable Ocean as a ministerial high-level and stakeholders conference next June on the 2nd and 4th of June in the Azores Islands. It will be an opportunity to discuss the progress of the current All-Atlantic Marine Research and Innovation Cooperation and launch an All-Atlantic pledging platform as a new approach to the existing cooperation and to accelerate the twin green and digital transitions, building a greener, fairer, and a more resilient society. And let me finish to stress two aspects or three aspects. One is that certainly we will need more funding and more research and more knowledge on climate change related issues. Second, that these issues and this knowledge gathering has to be made across disciplines. They are complex issues that need an across disciplines approach and also an across stakeholders approach. So everyone must be engaged in such endeavors. And as such, and this is my third and last message, is that we have to combine all funding opportunities from state budgets, national budgets, but also from European and regional budgets, as well as with funding from the private sector. This combined effort will lead us, we hope, to new solutions for this very complex problem. Thank you all.
Thank you, Helena. Thank you so much. Now it's time to hear Maria João Costa. She's an assistant professor and coordinator on the Earth Remote Sensing Laboratory, Institute of Earth Sciences at University of Évora. PhD in physics and an habilitation degree in Earth and Space Sciences, Atmospheric and Climate Physics. Hello, Maria João. Welcome.
Hello, good morning.
Good morning.
Thank you for your kind introduction. And
Say, sorry.
Yes. I was just thanking also for the invitation and the possibility to be present here. And yes, I will talk about atmospheric monitoring. You already have the first slide there. So just a quick note to highlight that today is Earth. Okay, you can see it.
Yes.
So it is a timely date to organize this conference, of course, and to discuss the Earth, the problems that we are facing, and also climate action. So we know that greenhouse gases are the most important contributors for global warming. You see there are several values. In fact, from February this year, the 417 parts per million mark was exceeded for carbon dioxide, and this is a value that marks the 50% above the pre-industrial levels. So 2021 will probably be the year when we see this stronger increase that will last for longer than a few days. On the lower right graph, you can also see the warming influence of the different greenhouse gases, and this interest has increased substantially over the last decades, and of course carbon dioxide remains as the largest contributor, followed by methane, which is another contributor. So, but not only greenhouse gases are the atmospheric players that are relevant for the climate system. In fact, they contribute to global warming, but we have other players, and you can see there the forcing agents, which are shown in the colored boxes. And apart from these greenhouse gases, we have aerosols. Aerosols are particles that are suspended in our atmosphere, and that also play a relevant role because they interact with clouds in different ways. And these agents, these forcing agents, cause what is called the radiative forcing, which in turn induces a change in global surface temperature. So there are several confidence levels attributed to several processes related to the estimates of radiative forcing. And what we do know is that the processes that include aerosols and cloud interactions are still processes that present a low confidence level of understanding. I'm sure you see the right slides. Maybe. Yes, okay. So we can see in that scheme that when aerosols, when aerosols interact with radiation, the processes are pretty clear nowadays. We relatively understand well what's happening. But when clouds enter in the picture, everything is much more complicated because aerosols can affect clouds in different ways, and this depends also on the types that we have, on the levels of clouds, on the state of development of these clouds. So here the processes are still poorly understood. I thought it was interesting to show you in a different perspective the artist's view of cloud aerosol interactions. Long ago, maybe in the beginning of the industrialization era, and you can see there that the smoke from the chimneys blends with the white clouds on the horizon. So this is in fact a manifestation how these particles can affect clouds in the atmosphere. So it is essential to improve our understanding on this subject of cloud aerosol interactions, because clouds are in fact playing an important role in radiation, and so they can I would say a very, very important role in future climate change. Maybe we still don't know how much, for sure we still don't know how much, but they will be very important players in the future. And satellites, remote of course, playing a very important role in the understanding of these processes, and has made advances in the understanding of these changes. I show here just a few examples. One of them has to do with the observational evidence of stratospheric cooling, and this cooling has to do with increased amounts of aerosols in the stratosphere. So aerosols in the stratosphere are mainly from volcanic origin, and they have the ability to reflect more radiation and thus cause cause a cooling effect in this region of the atmosphere. On the other hand, satellites are also very important to estimate global forcing, and these lower panels show some of observational evidence of increasing forcing, which is attributed not only to the increase in the greenhouse gas emissions, but also to a recent decrease in aerosol emissions, which are related with policies for air quality improvements. Another very recent publication shows that the lowest temperature on record was documented, in fact, a record of minus 111 degrees Celsius. So this means that clouds could be going higher in the atmospheric levels. Of course, this was one case, but there are some studies on trends ongoing. And of course, satellite remote sensing is also a great help to study clouds at different scales and at different atmospheric levels. Next slide. Okay. You see it? So we have here presented probability density functions of the radiative forcing attributed on one hand to aerosols, one of those forcing agents, and on the other to greenhouse gases. We can see greenhouse gases with a strong warming effect, and the curve is not so broad as that for the aerosols because the uncertainty related to this is not so high. So we see that aerosols, in fact, are counteracting the increase, the warming effect of greenhouse gases, and the total anthropogenic effect is slightly lower than that of greenhouse gases. And regarding these, both observations and models agree. So we just have to try and diminish the uncertainties and to better understand, but there's no doubt that the main effect of aerosols is that of cooling. So some time because I do not see the slides and I was trying to see them. So you see a lot of satellite images there. This has been a great help, is still a great help, and it will continue to be to study as we heard in the conference several aspects of climate, and here particularly I'm referring to the atmosphere and to the understanding of the climate system and to variations. Particularly, you see here three-dimensional structure of the atmosphere, and this enables us nowadays to retrieve several climate-relevant variables, atmospheric variables. However, this is not the only thing that we need. It is extremely important, but I would like to leave this message that we also need good quality ground truth measurements that complement this and provide the necessary assessments of observation from space. Nuno already mentioned in the previous panel the importance of ground-based measurements and networks, and this can be both from remote sensing or from in situ systems. They are indeed quite important. And I would like to see the next slide, but let's see if I can't. Okay, and on this note, I would like to conclude by mentioning very important effort that is for several years being set up in Europe, which is the ACTRIS research infrastructure that provides high quality data and information on short-lived atmospheric constituents. So these include aerosol, clouds, and trace gases. And it contributes, among other needs, with the necessary observations that complement Earth's observation from space, providing unique ground truthing of remote sensing information by current and also by future satellite missions. Actris is presently in its implementation phase. It started just a few months ago, and we are pleased to be one of the 22 participating countries in the research infrastructure. But when it goes fully operational by 2025, the required commitment to participate will no longer be scientific, but also political. Some countries already engaged in this, others, vertical, have not. We have just heard that FCT is happy to fund and to support research infrastructures. So we hope this will be possible also for Actris in the near future, and that by 2025 we can be a part of this consortium. This would be extremely important because this contributes to deeper understanding of climate change and will for sure be a valuable asset for high quality Earth observation data for life. So thank you for your attention.
Thank you so much, João, for your speaking, to share with us your knowledge and your discoveries. And now we have Joana Gaspar Freitas, environmental historian at the Center of History of the University of Lisbon, PhD in contemporary history, principal investigator of Dunes, Sea, Sand and People, a project supported by an ERC starting grant. Her teaching and research interests lies in the environmental history of coastal zones, considering risks and vulnerabilities, extreme events, climate change adaptation, coastal management, and the ocean's cultural heritage. A lot of things. Hello, Joana.
Good morning. It's a pleasure to be here with you today. It's a sunny day in Lisbon, and it's great to be able to talk about my favorite thing, the beach. Did you know that climate, space, and dunes are the ingredients of one of the best fiction issues ever written? Let me tell you about that. This story starts a long time ago in a galaxy far, far away in a planet called Dune. It was a planet covered by shifting sands. Almost without water, it was a dreary, hostile place. So its inhabitants had one main goal: to make their world green, to turn it into a self-sustaining system by engineering the entire planet. And they would do this by gathering water, anchoring the dunes, planting them with grass, bushes, and trees. They wanted to create a forest cover. These are the main elements of one great book called Dune, written by Frank Herbert and published in 1965, which is considered one of the best sci-fi books ever written. I brought this book here today because this is not just fiction. Herbert was inspired by reality to write his story. He was inspired by the works that he saw the US Department of Agriculture to do in the Pacific coast. They were trying to anchor, to fix the dunes by planting them, to prevent the dunes from being blown by the wind and move inland, where they were a menace to people, houses, roads, and highways. Herbert thought this was an amazing and extraordinary idea, but this was not new or even revolutionary, because in fact, This was pretty old stuff, at least in Europe, where dunes were a menace for centuries. In many European countries, we have stories of villages, agricultural fields that were swollen by the sands, of churches that had to be moved inland to escape being buried. And that is why the Parliament of Scotland in the 17th century forbidden people to pull the grass, the vegetation that grow in the dunes. For a very long time, the only way of coping with the moving dunes was to keep the vegetation that grew on the sandhills. So the dunes were a problem in Europe for centuries. They were seen as barren, worthless land. Nothing could grow there. So in the end of the 80s, was a French engineer called Bremontier that developed a strategy to fight the dunes at a large scale. He decided to plant them with vegetation and trees and use fences to prevent the wind from blowing the sand. His strategy was so successful that it was implemented in France and then in other countries. In Portugal, we have several examples of forests that grow in the dunes. And this was so effective that it spread to other parts of the world. But our ideas about the dunes change. Today, we do not consider them as bad dunes, worthless dunes. We think they are valuable, and they are valuable because they provide us with several important ecosystem services. And in times of climate change and rising seas, one of the most important ecosystem services is that the dunes are the best natural defense against sea flooding. So all over the world, they are being rebuilt, they are being restored to protect us from the sea. And this is being done using bulldozers, fences, and vegetation because, yes, the old methods of the 18th century still work and they prove to be very effective. So can we say that using dunes as walls against the sea is the solution for the rising seas? Well, not exactly. Nature never built fixed walls against the sea. Dunes are basically warehouses and distributors of sand. They cannot save us from the rising seas, but they can be very helpful to prevent damages, to protect us. But for that, two things. They can help us because they are buffer areas. They work as buffer areas. They blunt the force of the storm waves. But for that, we have to keep in mind coastal resilience. And for coastal resilience to work, to keep the natural balance of coastal areas, two things are really important. The first one is sand. We need sand to keep the balance between erosion and accretion. So we need sand, but we have a problem. Sand is vanishing. Sand is probably the most overlooked commodity that we have in our world. It's almost invisible, but it's everywhere in modern society because we use sand for almost everything, from concrete to build our cities, to glass, to the chips that we have in our computers and cell phones, even in our toothpaste. So sand is being taken from the natural systems where it's needed to build our human world. And for coastal resilience, we need space. When the seas, as the seas rise, the beach will have to move because there is no fixed coastline between the sea and the land. The beaches are always moving and they need space for that. But we don't have space, or in many places we don't have it because we built on the top of the beaches like we see here. So let me go back to history. Let me go back to history to talk to you about past populations. They avoid the type of coastal hazards that we have now by staying away from the danger. They did not live on the coast, and when they did, for some activities like fishing, mobility, seasonality, and perishability were the key strategies, and that this has to be ours too. We have to consider that in some places we need to retreat. We have to make room to accommodate the floodwaters, to move what is valuable above potential flooding level. We have to restore buffer areas like dunes to create an area, a protection area between us and the sea. Climate change is global, but adaptation measures to be effective must be addressed locally. Each place has its own history, so we need culture-specific, historically informed, and geographically rooted solutions. And we need new paradigms for the coast. We have to accept that the coast is moving and we should move along. We have to change ideas, and for that we need people to care. Ideas, perceptions, values, and emotions are the driving forces behind human societies. So how can we make people to care? Well, there are many ways, and we have talked about many of them in this conference. But as an historian, I suggest one. Use the oldest strategy of humankind to share knowledge and to survive, and that is telling stories. Helena Martins talked about that yesterday. Stories, fiction or non-fiction, are more effective than numbers to reach and engage people, to link reason and emotion and strengthen empathy. This is why I tell stories about dunes. Thank you very much.
Thank you so much. This is quite a sadist, because there's a sunny day outside here in Lisbon, and I'm trapped in the studio with full of images of beaches and sand and the sea. Thank you so much. We would like all to be in those scenarios probably. And now we want to hear, and I'm so sorry if I'm not pronouncing the name correctly. You used to it, right? I know by your face that you used it. Zaferis Kokinogenis, right? No? Are you telling that just because I'm nice, right? Because this is not the way we usually say the name. Well,
no, it's fine.
Okay. You're a data scientist, collaboration unit, smart and sustainable living in Ciência, including a PhD in informatics engineering at the University of Porto. Are you enjoying Porto?
Yes, pretty much.
Thank you. Additionally, he is a researcher at the Artificial Intelligence and Computer Science Laboratory at the Faculty of Engineering, also University of Porto. Welcome. And you have something to tell us about Ciência's view on smart and sustainable living, right?
Right. Yes. So today I will show you what is our vision about smart and sustainable living. It's common words that we're used to read in the literature of smart cities, but I think we undertake a different approach. So now we will showcase what we are doing exactly within these concepts. So before I start my presentation, I will tell you about Ciência, who is Ciência, and what are we doing. So Ciência is a Portuguese research and development center that works towards devising new technologies, products and services that can make society more sustainable. The last 15 years in Ciência, we have been working in innovative mobility products and services, and having the application spans between automotive development to electrified mobility and mobility as a service, a concept that in the last 4 years have drawn quite a lot of attention. Now, nowadays we use we are working towards a new concept, sustainability as a service model. That is that we focus on using technologies to develop new services and products that can allow us to decarbonize cities and urban places. Now, okay, so our roadmap, our research roadmap now can be summarized into these 4 directions. So first, we try to understand by sensing and monitoring what are the emerging patterns of people moving in the cities. Then we work towards on designing and producing user-centered, sustainable mobility solutions or services. Of course, being a company, we also need to look also to the business development issues, because this way we can finance our activities. So we are proposing new business models that can lead to decarbonization. And we are working also towards to improve the infrastructure that can help us to plan better urban environments. So, okay, let's start by giving an explanation about smart and sustainable living concept, the way we tend them here at CEIA. As we said previously, CEIA is also a collaborative laboratory, and we have adopted exactly this title, Smart and Sustainable Living. So by using the word smart, we intend to showcase solutions that are based on digital technologies and data-driven methods. Sustainable is because we try to optimize the resource allocation, but always with regards to social, environmental, and economic aspects that are part of a society. Okay, and then living, because we want our solutions, our products and services to be all-inclusive. Okay, and indeed to promote living conditions and improve living conditions in the city. So we work on the integration of these 3 aspects. Okay, to accelerate the transformation of the city into a sustainable urban ecosystem where people are the center of the attention. So our goals within this smart and sustainable living laboratory work is to advance the knowledge in order to address better urban and climate transition challenges. We try to advance techniques on urban data collection, analysis, and visualization. That's a very important issue, I think, because this way we gain insight and we can use them to deliver better solutions, and then of course to generate and push to the market innovative services and products that are focused on low carbon operations. Now, the components of our smart and sustainable living approach are unfold to 4 dimensions. So we have the policy development, we have social engagement, we have the development of new business models, and of course we have the technology evolution. And from these components we can understand that our team, our group also, our laboratory is quite multidisciplinary, having people from social social sciences, economic sciences, engineering, computer sciences, etc. So let's see now what is the approach we follow to deliver this sustainable as a service model. And first of all, our approach is quite special because it's a bottom-up approach where we put the users, the citizens, on the center of the attention of the products, of the services. So we are using three elements to devise solutions within this concept of sustainable as a service model. So we have the living Lab Matosinhos, we have the air, that is a green digital asset, along with the new cameras, that is the voluntary local carbon markets, a new proposal we are pushing. And then, of course, we have the digital twins computational approach to depict the sustainability as a service model. Now, what is the Living Lab Matosinhos? Living Lab Matosinhos is a collaboration between CEIA, some other companies here in Porto in Matosinhos, and of course the City Hall of Matosinhos. It's a space where citizens and communities work together in the co-creation and experimentation of new technologies aiming at a behavioral change, so we can achieve this decarbonization process. And of course, we can see it as an in vivo laboratory where we can test and experiment with the new proposals, the new solutions, the new services we want to put in the market. Of course, at the beginning in using large, small scale experiments, but almost with no limitation, and this exactly is because an agreement we have with the City Hall. Now, the other core element of our approach is the air and the local carbon market. So, air is a platform, is a behavioral economic platform that has the capacity of counting and valuing the CO2 emissions a person hasn't emitted because he opted for an alternative, a more sustainable mobility choice. For example, instead of using his own car, he's using a bicycle. So this platform is able to quantify and give a value, an economic value for this choice. So it's rewarding user for his actions. And then the user can exchange this value, this token, because it's in a form of credit tokens. So he can exchange the tokens for another services that can be part of this ecosystem. So the underlying technology of this platform is a blockchain. So we can have we have a way to verify the whole process of transactions between the quantification of CO2 avoided emissions and the generated value for the user. And then with this technology and with this approach, we then can establish a marketplace, so the so-called local voluntary carbon market, where not only citizens but also companies can participate and they can offset their emissions. So the last component of this approach is a computational model of sustainability as a service. So we use a digital twin approach, meaning we use a simulation-based approach. So as you can see here in the slide, so this approach, this component is built on top of 3 blocks. So we have the digital twins, where we have the real world or the real system we want to assess, and then we have its digital counterpart, and then we have a layer, a data-driven layer composed of a distributed machine learning algorithms and pipelines that collect data from observation from the real world, create insights, and then we have on top the mechanisms and processes where we have experts and stakeholders that can be or human or can be delegated algorithms that can produce policies and other interventions we would like to implement in the real world to steer this symbiotic simulation between physical and digital world. Okay, and with this, we can have the air platform mobility services and local markets to be used as our application domain, where now we can produce our hypothesis about the world we observe and test our hypothesis and test our understanding about this hypothesis before we decide that we have reduced sufficiently the uncertainty and we are ready to deploy our model, our business model, our application to the real world. So what will be next from here, our future developments? Our future developments will be focused on scaling up air in other cities. Now we are about to deploy the air platform here in the city of Matosinhos. Recently we have been awarded a grant from Google Europe within the context of climate change impact, and this, with the help of them, will allow us to deploy the air platform to other cities. Then we are working towards to understand the other domains where we can apply this air platform, not only mobility, but eventually other domains such as household energy consumption. Again, we intend to explore the 5G network communication capabilities to deploy edge computing services in the city towards to help us in the process of decarbonization. And last, to leverage on the joint projects CEA is involved within these small satellites of low orbit that will gather data, and we are intended to build a data hub platform where we can store and process the data, and our partners can use the data for performing their own studies about climate transition issues. So, and with this, I conclude my intervention. I think I took some minutes more than the regular, but that's all. Thank you very much.
Nothing too serious. Thank you so much. I remind that our audience that they can go to the chat and write all the questions and the doubts they have for this panel. We have now more or less 400 people watching us and being on the other side to listen, all our speakers and all the information they have to share with us. 400 people in the audience all over the world. Thank you so much. And now time to hear Sofia Serasoli, Assistant Professor in Forest Research Center, School of Agriculture of Lisbon, and researcher of the Forest Research Center. She has a degree in agronomy from Università di Perugia and a PhD in forestry from Instituto Superior de Agronomia. Her research activity focuses on the impact of climate change on Mediterranean forests and the use of proximal and remote sensing for vegetation monitoring. Hello, Sofia.
Hi, Rita, and thank you for the nice introduction, and thank you, everyone. Thank you for inviting me to this conference. I'm really honored. I would like first to stress a few words on our research center, the Forest Research Center, and generally the School of Agriculture is strongly committed on a vision of forests that, while pursue the economic activity, is also strongly committed with the ecology and strongly aware of the global problem of climate science. So ecology and economy go on the same, of the same importance. And so while we look to the importance of when we are aware that problem is global, and we look to global network, and that problem need to be solved through science. We also are aware that we need to provide the stakeholder forest managers with useful, cost-effective tools that could helpful in applying sustainable practices. So it's really a nice day in Lisbon. We already went to the beach. Now take a walk through the forest. Forests are okay. We know that remote sensing can provide several many information about biophysical traits of forests, not only land cover, or greenness, which are the main known features provided, but also pigments concentration, or in the future, it's now widespreading the use of fluorescence chlorophyll for studying photosynthesis. And all these features are then integrated eventually into models. The previous speaker, Nuno Carvalhais, explained this very well, so it helped me the floor to go further and show you some and go further in my talk. This is just is an example. This is the first model obtained from first global model of forest productivity obtained from a satellite, which is the MODIS product. And there's after that, many other models have been produced, and this model is very useful to understand the trends of the impact of climate at the global scale in the different biomes. But when we work at local scale, its usefulness is quite reduced due to the low spatial resolution. So it is. Okay. So this is an example of how ground data could help to improve improve models and help at local scale. And before me, both Isabel Trigo and Nuno mentioned the importance of ground validation. So ground data, the collection of in situ data, it's what I'm going to show you in the next examples. In this easy example, we use it in situ data of carbon sequestration to test different models and test different data sources, and then build up this local map with high resolution and a temporal resolution of 15 days. That could be used for a short-term monitoring on the ability of the ecosystem to collect activity of the ecosystem facing actual climate conditions. So, another problem when we have a large, when we look from when we look to the forest from the space, it's frequently the heterogeneity of the ecosystem. This is particularly true in one of the most typical ecosystem of the Iberian Peninsula and the Mediterranean region, and very frequent in Portugal, which are Mediterranean woodlands. These are heterogeneous forests in which both the trees and both the understory, the grass and the shrubs, contribute greatly to the carbon balance of the forest. So, and the problem here is how can I understand which is the response of the ecosystem to the climate, while when trees and grass respond in different ways to have different physiological and structural response to climate drivers. So for this reason, we decide to do in situ collection of optical data, which are similar to the ones we obtained from the satellite, but they can be specific, and the target are the different vegetation types. And this sense in the figure on your left, you can see on your right side, sorry, you can see how easily the spectral or vegetation in this obtained can distinguish the response of the trees, which is the almost flat line on the top, and the understory to the climate. At the seasonal scale, we see very well the response of the grasses to the seasonal, and also the interannual variability, as you see the different peaks of the difference in peaks of the grasses. So I am convinced that this sensor has in situ could be useful in as they are useful similar sense in smart agriculture, could be useful also in precision silviculture to address issues related with the vegetation facing abiotic challenges. And we use this the response of this sensor to address and to model the how vegetation responds to climate. On a set on you can see here highlighted with an arrow the different response of grass and the cork to precipitation in the seasonal scale. Finally, we also used the in situ data to validate also remote sensing data. We use it to obtain phenology estimates. You can see very well, but the green areas are the periods of the green the growing season of the understory, and the different and we defined how precipitation timing and amount impacted the growing season lengths. And to validate this data from the remote sensing, we used in our in situ data. So finally, while we are convinced that in situ sensor can be useful, we are also working to bridge the gap using models, specific models, and the detailed characterization of the sites through UAV imagery. Okay, so finally, in my last slides, I would like to explain a little bit what I am doing in the framework of the research infrastructure per biota, where we already work here of the importance of sharing the information. So our first our first activity will be to build up a spectral library, collecting all the in situ data we collected. So and offering this data, providing this data for further studies that we think could be quite useful. Then stressing again the importance to enabling practical solution, cost-effective solution in the area of forest management for using remote sensing, using both in situ and remote sensing data. We are planning to set up operational workflow, provide different alternative solutions, and provide specific training to the stakeholder to promote the implementation of the use of remote sensing in a forest. And that's all.
Thank you. Thank you, Sofia. Now we have already some questions from our audience, and we'll start with Helena. Helena, are you still with us? Can you hear me?
Yes, I can hear you. Yes.
Okay, Helena, we have this question. Climate action and resilience is strategic for European. You mentioned a significant investment in research at national level with different initiatives and researches. Does FCT blend national funding with the Atlantic countries and EU funding incentives?
Yes, well, of course.
Yes. Because I have another question that probably you can include in this answer. And does FCT also bridge with the Portuguese-speaking countries that are fundamental in this climate adaptation global network? Probably you can make all the package in this in one answer.
Yes, and I will in fact answer in a more general way. Reinforcing what I have said in my keynote speech is that these climate change issues are very complex, and we need to address them at various disciplinary and actors levels. Of course, combining efforts not only from each country, for instance, Portugal, as well as the regional, at a broader regional level, like, for instance, the European level. And this is of paramount importance that we cooperate in platforms, in programs, in every instruments of collaboration with other areas of the globe. Europe, certainly, but also Africa and Latin America and Asia, with a perspective of the Earth is just one, and we will suffer globally of the effects of climate change. So, of course, the funding of such platforms, the funding of the different aspects of research are certainly important, and we need to increase them. There is a general commitment of all countries of addressing the climate issues with a focus in our next programming period. So this applies to Europe, and it applies to Portugal as well. So climate changes are one focus of funding, meaning incentives in all instruments. So as I also told you, ideas, people, and platforms and infrastructures, certainly.
Thank you, Helena. And now the next question from our audience to Maria João Costa. With a compliment, first of all, you develop a fantastic work at the Earth Remote Sensing Laboratory and cooperate at international level. Will your team be also closely involved with the newly launched Knowledge Center on Earth Observation?
Sorry, I hear very bad. Can you repeat, please?
Yes, of course. Did you hear the compliment? Because this spectator said something very nice. First of all, he said, or he wrote, "You develop a fantastic work at the Earth Remote Sensing Laboratory and cooperate at international level. Will your team be also closely involved with the newly launched Knowledge Center on Earth Observation?"
Well, thank you for the compliment. Well, for sure, we have plans to be involved in whatever is useful for our activities, and so yes, we do have plans to use it. We work. Today I focused on atmospheric, but on atmospheric parts. But in fact, we developed work in remote sensing also of land and water surfaces. So yes, this is a plan. Thank you.
You have a low signal there in Évora. You have to resolve that with someone. We can hear you clearly,
Yes,
but the image is not perfect. You stop a little a little bit. Sorry, but we hear loud and clearly, perfectly. The sound is incredible. So next question now is. Sea level control and sand management are the core of your presentation and work. To reach the citizen level, storytelling is important, but the political and regional policies have a fundamental responsibility. Is this message sufficiently passed to the policy level for tangible results and urban and building planning? This is a very important question, because the regional policies and administration is quite important for your work, the decision area.
Yes, I think one of the problems is that when you talk about climate change, we always talk about the present and the future. We hardly look at the past. But when you try to address local issues, local adaptation measures, you need to engage the population, and you need specific policies for those places. And history is full of data. Is full of the data of humankind, the way we have been dealing with problems, because climate change can be a present issue, or it seems, but climate change has been with humanity since ever. We have experienced very different climates along our thousands of years on Earth. So looking back is important. And I think in my work, an historian working about the sand and the sea is something different. When I tell that I'm a historian and I work about the sand, I think that always raises curiosity, and that is a good way of starting a story. It's very important that we engage people, and we are not engaging people if we scare them or if we only show them numbers. It's easier to call people's attention if we tell them stories, if we feel their emotions and their values. And this was also talked yesterday, the importance of bringing emotions, values, into this discourse, because the policies can be very good, and we have very good policies in Europe and in Portugal, but if people do not apply them, they will not be enough.
Thank you very much. Next question for the audience to Zaferis. Zaferis, at CEA, applications and smart mobility solutions have been developed, and you have pilots and living labs in different regions in Portugal. Are these solutions ready for full deployment and to be used European Union-wide? You also mentioned AIR, application functionalities. How big is the acceptance and use of this app, both by citizens and goods providers, to exchange clean mobility usage by pocket goods?
Okay, sure. We are ready to go full deployment now in Matosinhos. So we are about to integrate bike sharing services with public transportation. And also we have some companies here in Matosinhos have expressed interest into participating. So I think the level of acceptance will be high. At least from some first analysis our colleagues have performed in a kind of survey state preferences, and also the fact that Google has accepted us has granted us a funding to deploy the air platform to other European cities, I think means a lot. So this is an acknowledgement of our efforts. So, and we believe that we will be able to deploy the solution not only here in Portugal, Matosinhos, and I think near Lisbon, Cascais, but also in other European cities. At least these are our plans.
Thank you, and they're quite a project and really good plans. And now for Sofia Serasoli. Like some other speakers of this conference, you mentioned the importance of local validation of data collected through satellites. At scientific and research level, this is commonly done. Nonetheless, are there instruments in place to allow the involvement of the normal citizen and local farmers to also contribute to widen the collection of information and add data for validation?
Actually, not really. The involvement of citizens it's not active in this collection of data. But yes, I think it could be an opportunity for engage the general public in the awareness of climate science and the importance of forests. But now we are not. I'm not aware of any activity in this side.
And now again, another question for Helena from the audience. This time I have a name. It's a question from Rui Salgado, and Rui asks, given the importance highlighted in this conference of international networks and infrastructures linked to the monitoring of the atmosphere, I come to ask the following question, addressed to Professor Helena Pereira. Is Portugal scheduled to participate in ACTRIS and or ECOS, ICOS?
Yes, Portugal is involved in that, and let me stress one agency, one organization in Portugal that deals with these aspects of monitoring and space-related issues. I did not mention that on my talk, so this is a good opportunity that I can now talk about our Portugal Space, which is our agency devoted to the aspects related to space, and of course the interactions between space and Earth. So this is the agency which is a joint action of four associates. FCT, the funding agency is one of them, as well as the Innovation Agency, the Government of Açores, and the Ministry of Defense. So we are the four associates that built together the Portugal Space Agency, and they will be very much involved in these platforms. Thank you for allowing me to speak of that.
Thank you, and thanks to all of our speakers, mostly you women. Sorry about that, Zaferis, but I have to applaud this participation, so feminine, because it's needed most of all. Thank you for your share of experience, projects, research and knowledge. They are so important. They are vital to make us all more clear about what we have to do in mitigating climatic changes. Thank you so much. Please stay with us. And I invite also the audience to keep in touch with us for the next panel. After a small break, we have to have some lunch. We have to feed all the team that's behind this conference. So if it's time for you to lunch at your country, go for it. If not, take a break and come back in about 1 hour. See you then.